Hello and welcome to this Medic Mind tutorial. My name's George and today we're going to be focusing on pin code questions, and these are taken from section 1. Now, because they're pin codes and because they involve a lot of logical reasoning, some candidates find these more of the harder ones in the BMAT. So hopefully today will be especially useful for getting you to grips with these type of questions. Now, there are 3 lesson objectives of today. First, we want to introduce you to using algebra in this type of question. And that can be very helpful when you come onto the more convoluted ones where there are several rules underlying the pin code. Second, it's really important that you learn to read the question stem properly, because often you can miss little bits and pieces which can screw you over at the last part of the question. And after you've done all of the working, it's a real waste to mess up at the final hurdle. So we're going to be helping you avoid that situation. And finally, as always, there'll be several worked examples in today's video. So how do you approach pin code questions? Well, I said before, most candidates find these more difficult than every other question in the BMAT, and that's why it's important to have a number of tips and tricks at your disposal. One of the ways you can do that is by using algebra and mathematical models, but often it also involves a lot of trial and error. But as I always say to my students, it's intelligent trial and error. You don't want to just be guessing randomly, you want to have some sort of strategy behind your trial and error. Now, these have appeared quite frequently in the recent papers, so it's really important that you pay attention to this video and spend your time revising this if you need to. So let's begin with question 1. Pause the video now and have a go at the question. Okay, let's go through it together. Now, often these questions will take the style of someone has forgotten their PIN code, but they remember these convoluted rules about what the PIN code involved. So, let's deal with those rules. A person has forgotten their 5-digit PIN code, and with these questions I really like to write down how many digits it has as little dashes underneath, so I know what numbers I've got left to fill. So let's do that right now. So we've got 5 little dashes for the 5 numbers. Now, we've got several clues. We know that the second digit is the square of the first digit, the sum of the first and third digits is 10, the fourth digit is one more than the first digit, the sum of the fifth and third digit equals 14, and all of them together equal 30. So, if we just label them A, B, C, D, and E, we can start writing down some crucial rules. Now, we know several things. We know that A is equal to A, obviously. We know that B is equal to A squared. We know that C is equal to the sum of the first and third digits is 10. So we know that C plus A equals 10. Now at this stage, I'm just going to rewrite that so that it's in terms of C in order to keep us clear. So if we just undo that, we know that C is equal to 10 minus the first digit A. D, well, we know that the fourth digit is one more than the first digit, so that's A plus 1. And then finally, E, we know that the sum of the fifth and third digit equals 14. So E plus C is equal to 14. Now again, I'm just going to rephrase that so that it's in terms of E. So let's do that right now. So E is equal to 14 minus C. And again, it makes sense because if you look at the 4 previous equations, they're all in terms of A. Let's just put that last one in terms of A too, just to make it simple for us. So 14 minus C, we know that C is 10 minus A, so if we replace that, 10 minus A, okay, expanding out those brackets, the minus stays with the 10, but obviously because we've got minus A, that turns into a plus, so we end up with 14 minus 10 plus A, so that's 4 plus A. And we know that all of them together are equal to 30, so we can set up an equation. We know that A plus A squared plus 10 minus A plus A plus 1 plus 4 plus A is all equal to 30. So let's write down that equation now in blue. So A plus A squared plus 10 minus A plus A plus 1 plus 4 plus A is all equal to 30. Simplifying that down, we've got an A here, an A here, an A here, and an A here. So that's 1, 2, 3 minus the A, so that's 2A. And we've got the A squared, remember? So we may as well put that at the front. And then the digit, we've got plus 10, plus 1, plus 4. So altogether, that's plus 15. And that equals to 30. Taking that 30 onto the other side, we end up with a squared plus 2a minus 15 is equal to 0. Now at this stage we can solve that because we can look for factors of 15 that add together to get to 2. Now those factors, and we'll put it over here, we get a bracket a, and we get minus 3 and plus 5 is equal to 0. Solving for this, you get a equals minus 5 as well as a equals 3. Obviously a can't be minus 5, so in this case a is equal to 3. The first digit is 3. You can see how algebra can be a real powerful tool with these questions and can really help you sort through in order to fully understand the question. So the correct answer here was 3. Now with this one, it's also worth saying that as you get familiar with these questions, you can employ different strategies. So with this one, if we just recap again, we've got 5 different digits. The first one is the square root of the second one. That means that it can only really be 1, 2 or 3, and we can write that down as possibilities here. The second one is the square, so it can either be 1, 4 or 9. The sum of the first and third digit is 10, so we've got 9, 8 or 7. The fourth digit is one more than the first, so we've got 2, 3 and 4. And then finally the sum of the fifth and the third digit equals 14, so we've ended up with 5, 6 and 7. Hopefully you can see that we've got different strings of numbers. We've got one row here, and one row down here. We can add those up and see that only the last one totals up to 30. And that can be another alternate way which we can work out the answer. But the point is, if you're lost, algebra can be a really good starting point to help you come to terms with a question. And that's why this answer is 3, no matter which way you go about it. So as I've been saying, there are often multiple ways you can go about a question. And if you're stuck, it's always good to revert back to what you know from GCSE and A-level. Use these tools to help you answer these problem-solving questions. So it would be a good idea to brush up on your algebra to help you get to grips with these more complicated questions. Moving on to our second question of today then. Pause the video now and have a go at this one. Right, again, this is a more convoluted question. It's a pin code question. It can be quite difficult to get to terms with. So, like I said before, I'd like to write down how many digits we have in the form of little dashes to help. So in this case, we have 6. 1, 2, 3, 4, 5, 6. We know that the second one is 8, so we can fill that in right now. We know that the last one is a prime number less than 5. Now, there's no point in writing down that rule because we can quickly work out what prime numbers we're talking about. It's either going to be 2 or 3. So we can write down those 2 possibilities in green. We know that when we pair them up according to 2-digit numbers, so if we pair them up like this, and like this, the answer, what does it come out as? Well, it comes out as 170. We know that when we pair it up as 3-digit numbers, so like this and like this, the answer comes out as 1610. You can see just with that little diagram, I've captured all of what the question is talking about. I don't need to worry about what the specifics of the words were anymore because I've captured it in my notes. All of the information I need to answer this question is right there in front of me. Now, if you're stuck with those questions, remember that. You've got all of the information you need. You have to start in this place and you have to eventually get to the answer. So, given these numbers on the page, there has to be something that we can do. Now, we've filled in 8 and we've filled in 2 and 3. The only thing that we haven't used so far is those 170 and that 1610. So thinking about it, if we're adding up 2-digit numbers and it ends as a nice round multiple of 10, then those digit values, the 8, this position 4, and this last position, must all total up to a multiple of 10, because there's no sort of unit value at the end there. So let's say 8, let's assume 2, the only missing number is 10. Like, to make it a multiple of 10, you have to have 10 or 0 in that fourth position. So given that we can't have 10 because it's a single digit number, we must have 0 in that position if we were to assume that 2 is at the end. Let's think through it with 3. If we had 8 plus 3, that's 11. To make it up to a nice round multiple of 10, we have to have 9 in that fourth position. So let's write that there. The 9 pairs with the 3. At this stage, we've kind of exhausted what we needed from that 170. So let's look at that 1610 and just think about what that means. Now we're either adding up a 3-digit number here plus 900 and something 3, or 0 something like 82 or something like that. It makes sense that 9 goes in this position because we've got to get all the way up to 1600. Now if this was 0 here, we'd have to do all of the work in this first 3-digit number, if that makes sense. So hopefully you can see that we can easily rule out 0 and therefore 2, because if those were the numbers, we simply wouldn't get anywhere near this 1610. So the correct answers here would be 8, 9 and 3. So we can circle that 9 and 3 there. Moving on then, we're now looking at the first and fourth numbers, because that's what the question asks us. What do the first and fourth numbers add up to? We know that 9 is in the fourth position, so to get close to 1610, we need quite a high number in position 1 as well. Now, if we put 7, for example, in position 1, we would get to the 1600 because we'd have 700 and something plus 900 and something. That would give us 1600 and something. However, we have an 80 here. That's an 8 in the tens position in this 3-digit number. So actually, if we put a 7 in position number 1, we'd have gone over that target of 1610 because the 9 and the 7 would add up to 1600, and then the tens units would take us a bit too far. So actually we've got to go 1 less, and that means that 6 has to be in this position. At this stage we can confidently answer the question. We know what's in the first position, we know what's in the fourth position, therefore we can say that they add up to a nice round 15. That will mean when we group them as 3-digit numbers, we get 1500 and something. Now hopefully you can see that this 8 would pair up to this 5th position to help us get over the line to 1610. And that's why I said before that a lot of these questions involve trial and error, but it's an educated trial and error. If you know what you're aiming for, in this case 1610, we can intelligently pick numbers that will help us get there. So, all in all, the answer here is 15, that's answer C. So with that last question, hopefully you could see that we didn't have to work out the whole of the pin in order to get to the question. And that's a common theme with these questions. Sometimes there'll be ways that you can go about it so you don't need to work out all of the numbers involved, and that can save you time. Equally with the last one, we were asked in the question, what does the first and the fourth digit add up to? Now if you hadn't spotted that, you might easily have just gone with what was the first digit, or what was the fourth digit, or what was the pin entirely. It's important to pay attention to the question so that you don't end up working out the whole pin and then falling at the final hurdle because you don't do specifically what the question wants you to. And the next question will demonstrate that nicely. Okay, here's question 3 out of 4. Pause the video now and have a go. And remember to pay attention to what the question is asking. Okay, so again we're left with this forgetful credit card holder that's forgotten their pin. So in this case we're dealing with a 4-letter pin, or a 4-digit pin. We can write that down in our familiar dash format down there. We're told that when the number values are written out as words from the first to the fourth number, they're all in alphabetical order. Then we're given some information which really does actually help. The first digit of the Alice's pin is 4 and the last digit is 3. So let's write those ones in. 4 and 3. Now, not only is their numerical value important, it's also how they're written out as words. If we write them out, 4 is our first one, and 3 is our last one. We know that we're going to go in alphabetical order. So let's work it out. We know that none of the other digits are square numbers. So what numbers are we left with? Well, it can't be 1 because 1's a square. Could potentially be 2. Could potentially be 3 or 4, but we've already got those. Could be 5, so let's write that down. 6, 7, 8 it could be, but 9 is a square number, so it can't be that. So we're left with a choice of 5. To help us work that out, we now need to consider what they are like as words. Now 2 is T, W, O. That falls after 3 in the alphabet in terms of if you write it out as a word, so we can cross off 2. Likewise, 5 is spelled F-I. That should appear before 4. So actually, we can cross off 5 because we know that 4 is the first letter, or the first number, sorry. 6, 7, and 8 we're left with. Now 8 starts with an E, so obviously E falls before number 4, the F in 4. So actually we can cross out 8 because we know that this code starts with 4. So we're left with 6 and 7. Now obviously 7 has S-E and 6 is S-I. So actually in alphabetical order, the correct code would be to be 7 followed by 6. Now let's look at the question. What is the total number of letters that make up the second and the third digits? In this case, 6 and 7, it's really tempting to add those and say 13. But pay attention, it's the number of letters. 7, if we write it out, has 5 letters, and 6 has 3. So 5 plus 3 is 8, and that's answer option C. Now you can see with these questions, they can be quite convoluted, and you might see them and think, whoa, calm down, I don't know what to do with this information. But just like with the previous ones, if you write down all of the information you're given in a nice pictorial way, at the end of the question, you're looking at a nice picture which has all of the information that you need. And that means that that's the only information that you need. So you can start there and then carry on. Don't get overwhelmed by the whole calculation that you might need to do, because it's important that you have the information as a starting point. You will then go through a series of stepping stones in order to eventually get to the right answer. So always try and find any explicit information you've been told and work your way from there. Now let's do a question which demonstrates this. So this is our final question of today, question 4 out of 4. Pause the video now and have a go. Okay, so with this one, we're given a list of names again, and this dad has to pick some sort of combination of names, as is often the case in real life. So we're given an unreasonable number of names, so it's not possible to really write these ones down, because quite clearly you'd have to write out all the name, because otherwise you'd get Solth, Samuel mixed up, you'd get John mixed up, Aaron and Alex. All of them start with roughly the similar sorts of letters, so actually it's not worth writing these ones down. However, we're told that he's tried a combination: Samuel, Lawrence, John, David and Aaron, and we know that they're meant to be in reverse alphabetical order. The lifeguard then tells the dad that the password is wrong, but the first, fourth and third names are in the correct position. So we know that Samuel is correct, we know that John is correct, and we know that David is correct. Now, don't ask me why the lifeguard knows this, but for some reason he does. So the question is really focused on the last 2 remaining names. It's not Lawrence and it's not Aaron. So we can immediately cross off answer option B because that has Lawrence as the second one. So what can go at that rightmost position? If it's not Aaron, it has to be equally something that begins with a letter of the alphabet before D. Now, we've used David, so the only one that really applies now is Alex. It has to be Alex at that rightmost position. So let's write that down. If we then look at the answer options again, we can see that actually 2 of them have Alex in that right position. It's either A or D. It's worth comparing these answer options at this point in order to find out specifically what you need to work out. You can see they only differ in their second name, Lisa and Killian. Now we can then revert back to our rules. They have to, for example, go in reverse alphabetical order, but actually both of them satisfy that rule. The only other rule is that at least 2 names must have at least 4 letters. Now, all of the names have 4 letters, so we're fine on that front. So we might be a bit stuck, but if we'd paid attention to the question and look back at the children's names, you can see that actually Killian isn't even a child. So that makes it very easy, and we could pick answer option A as the correct answer. So what then are our take-home points? Well, first, we introduce you to using algebra in questions. It's not always the quickest way to go about a question, but it is the most robust, and it's a good starting point if you're confused about where to begin. Second, we told you how to read the stem properly. Remember in those questions where it asked about the number of letters, for example, it's easy to trip up at that final hurdle. So pay attention to what the question stem is asking and not just what you find convenient. And finally, we went through 4 worked examples which give a good breadth of these pin-type questions. Remember, you can write it down on your paper in a nice pictorial format, and that's all the information that you have, which is quite comforting to know because you have to get the answer from that limited information. So start at the beginning, work your way through the stepping stones, and hopefully you'll get to the answer eventually. And that's the lesson complete. I hope you enjoyed that. My name's George, and I'll see you again next time. Thank you.